Okay, here we go with your introduction to the unit circle. So frequently, students see a question such as, what is the cosine of 30 degrees? And they think, help, I need a calculator. Or what is the sine of 135 degrees? Ayúdame, where's the calculator? But you, in that precious brain of yours, can solve these. Just wait. So, what you have to memorize or know is the simple special right triangle relationships. So, for a 45, 45, 90, whoa, I like that one. For a 45, 45, 90 triangle, if the hypotenuse is 1, the sides are going to have lengths square root 2 over 2 and square root 2 over 2. These angles are the same, so these sides are the same, and this you just have to know. So understand that this is less than 1. I think it's 0.707. Let me double check that. Square root 2 divided by 2. Wait, what? That's not right. Oh. Square root 2 n parentheses divided by 2, 0.707. Okay. And in the 30, 60, 90, if the hypotenuse is 1, we say the short side is 1/2 and the long side is square root 3 over 2. Okay, so you might remember those from geometry. If not, there they are. That is something that you actually just have to know and have in your head. But that's it. So, no problemo. Alright, you can have these numbers, root 2 over 2, 1/2, and root 3 over 2 in your head on demand to apply to this concept of the unit circle so that you can figure out sine and cosine ratios in your head without using the calculator. It's pretty cool. We call the unit circle because frequently in math the word unit is used to refer to 1. So within the unit circle, the radius of the circle is 1, and we're going to be drawing triangles in the circle to represent these angles, and the hypotenuse will always be 1. So here's the bottom line. The bottom line is that when we're talking about measuring angles, we always start from right here, and we move in the counterclockwise direction. So if we were to talk about some angle theta, this could be, what, 50 degrees or something? We would start here, and we would move our line in this direction until we get to 50 degrees. So there's our 50-degree angle. We then draw a right triangle. So we're going to bring, we call this the terminal point or something like that. So we always bring this towards the x-axis, and voila, we have a right triangle. In looking at that right triangle, if we're talking about this angle theta, we know that this would be the adjacent side, and this would be the opposite side, and this would be our hypotenuse. So I will write that the hypotenuse, and we know that that's 1. This is the opposite side, and this is the adjacent side. So what we can say is that we know that the sine of the angle is the opposite over the hypotenuse, and see how I'm just writing 1? The opposite side divided by 1 is just the opposite side. And we can say that the cosine of the angle is the adjacent over the hypotenuse. Dividing something by 1 is just itself. So we arrive at this conclusion where what we're actually thinking about, is this is a coordinate system, right? The x, y axes, where this would be out of x equals 1, this is y equals 1, x equals -1, etc. And we're looking at the coordinates of this point, and it turns out that the cosine of the angle is the length of the adjacent side, which is the x-coordinate of that point. And it turns out that the sine of the angle is the length of the opposite side, which is the y-coordinate of this point. So we can think about x comma y, and the generalization then is that the cosine of the angle will be x, and the sine of the angle will be y. And this triangle that we've drawn is going to be one of the two triangles we saw on the previous page, the 45-45-90 or the 30-60-90. So this is the moral of our story, and we will apply this to several examples. This is the moral of our story. Cosine of the angle is x, sine of the angle is y, hypotenuse is 1. Ready? Yeah. So let's see. Here's our first example. We have an angle of 60 degrees, and what we're interested in is what is the cosine of 60 degrees and what is the sine of 60 degrees. I wonder. And so from the previous page, we're thinking cosine is x, sine is y. We're also thinking I'm going to take this angle, so again, between here and here, 60 degrees, I'm going to take this angle, I'm going to draw a right triangle. So from our terminal point, we're interested in the xy coordinates of that point. We're going to make a right triangle. And when you look at the triangle, so you've drawn it, you're looking at it, you recognize that that is a, and hopefully you didn't think 45-45-90, you thought, well, there's the 60-degree angle, so I know this is a 30-60-90. You know that the hypotenuse is 1, and from the previous, from page 1, we know that the short side, so if you've drawn it somewhat correctly, this should obviously be the short side, this should be the long side. So we have 1/2, and we have square root 3 over 2. So back to what we said about sine being the y and cosine being the x, so we can simply say that the cosine of 60 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. Is it that easy? Yes. So if you ask your calculator, make sure you're in degree mode, type in cosine of 60 degrees, it's going to tell you 0.5. And what is the sine of 60 degrees? It's going to tell you, it probably won't say root 3 over 2. Let's see, Mr. Calculator, what do you say? I think that's 0.866. Sine of 60 degrees, and enter, and it's 0.866 with a bunch of decimals. So this is the exact form. Calculator will say 0.5, and calculator will say 0.8660253. Whatever. Cool. Let's try another example. So here we have a 45-degree angle. So again, between here and here, 45 degrees. We are dropping a line down to the x-axis from wherever we are. And this triangle we probably, hopefully, certainly recognize as a 45-45-90. We know that the hypotenuse is 1, therefore the lengths of the sides are square root 2 over 2. This is the x coordinate of this point. This is the y coordinate of this point. So we can say that the cosine of 45 degrees is square root 2 over 2. And your calculator will tell you 0.707. Yeah. And the sine of 45 degrees is the y coordinate, and that is root 2 over 2. Wait, is it that easy? Yes. Another example. This is looking pretty blank. Okay. Oh, here's what I meant to say. Alright, so let's try. We're looking for the cosine and sine of 90 degrees. So, 90 degrees, let's see, we're starting from here and we're going in the counterclockwise direction, so the 90-degree angle ends up being here. And frequently when I'm explaining this to students and we get to this point, they get here and they start drawing some triangle like this, and then they get confused. Remember, the whole purpose of the triangle is simply to figure out what the x and y coordinates are of this terminal point. So we had something out here, we were interested in xy, and so we drew this triangle. But if you think about it, oops, hey, go back. If you think about it, we already know the xy coordinates of that point. Remember, here's our Cartesian coordinate plane, our xy axis, and we're really zoomed in. The unit circle, watch this, the unit circle is right here. Alright, so here's one, here's one, here's one, and here's one, and here's the origin. So when we think about the unit circle, here we are, okay? So here's our unit circle. Here's our 90-degree angle. What are the xy coordinates of that point? Well, x is 0 and y is 1. So wait, are you telling me that the cosine is just 0 and the sine is just 1? Yep. So what we're getting at here is that the cosine, x coordinate of 90 degrees is 0 and the sine of 90 degrees, the y coordinate is 1. Don't believe me? Ask your calculator. Alright, so that's it for part 1. In part 2, we're going to look at angles that are greater than 90 degrees. Thanks for listening.